Hi there and welcome to Ola Gold Academy. Now on the board, we're having questions involving the use of dilution formula. These are questions from a topic which is mole concept in chemistry. Now, question 1 says, what volume of distilled water should be added to 250 cm³ of 2 mole per dm³ hydrochloric acid to make a 0.05 mole per dm³ solution? Now, these questions here can be solved in two methods. I'm going to use the first method, which is the use of dilution formula, and also I will make use of the normal method, which is concentration equal to mole over volume. Now, without wasting our time, let's quickly go into the calculations. And the question says, what volume of distilled water should be added to 250 cm³ of 250 cm³ of 2 mole per dm³ hydrochloric acid to make a 0.05 mole per dm³. Now, this is how we derive the dilution formula. Now, we have that concentration equal to mole over volume. We have this. Now, from here now, we can make this mole to stand alone by cross multiplying. So we have n times 1 give us n, c times v give us cv. The c here is concentration and the v here is volume. Now let's recall from Boyle's law. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided that the temperature is constant. Now, from Boyle's law, to remove this sign of proportion, what do? We introduce constant. So we have P equal to K over V. Now, to make this K to stand alone, we do what? Cross multiply. So we have K equal to PV. Now, from here, on the account of two pressure and two volume, it becomes P1, V1 equal to P2 and V2. We have this. Now the same thing applies to this place here. From here we are going to have C1, V1 equal to C2 and V2. So we have this. So this is our dilution formula. This is our dilution formula. C1V1 equal to C2V2. Let me make it a little bit bolder. C1 V1 equal to C2 and V2. Alright, from the question we are having here, what's our C1, what's our V1, what's our C2, what's our V2? As usual, in gas loss, the first concentration we find becomes our C1, the first volume we find becomes our V1, the second concentration we find becomes our C2, the second volume we find becomes our V2. Alright, from the question says that what volume of distilled water should be added to 250 cm³ of 2 mole per dm³ HCl. Now, as you can see that 250 cm³ is coming first. So this 250 cm³ becomes our V1. And let's not forget, it's in cm³, but we have dm³ here. So what happened? We change from cm³ to dm³. Now listen very, very attentively. If they are all in cm³, there is no need for conversion. If they are all in dm³, there is no need for conversion. But since we are having cm³ here, dm³ here, what do? We convert 250 from cm³ to dm³, and we convert by dividing this by 1000. So 250 over 1000, 0 cancels 0, so we have 0.25 dm³. So we have this. Alright, let's list out our parameters from the question that we are given. Alright, now our V1 equal to 0.25 dm³. 0.25 dm³. Alright, our C1 becomes 2 mole per dm³. Alright, our next one we are having is concentration, so it becomes our C2. So our C2 equal to 0.05 mole per dm³. Now, this volume here becomes our V2. So our V2 equal to question mark is now unknown. Now, from here, since we are looking for V2, what do? We make V2 to be the subject of the formula. So we have here, we divide both sides by C2 to make V2 to stand alone. So we have over C2 over C2. C2 cancels C2. So this implies that we are going to have V2 equal to C1 V1 over all over C2. So we have this. Alright, so next thing we are going to do is to input our parameters. So V2 equal to, our C1 is what? 2. Our V1 is 0.25 all over, our C2 is 0.05. So our V2 becomes, multiply this times this and divide by this. What do we have? 2 times 0.25 divided by 0.05. So our V2 becomes 10 dm³. So we have this. We have this as our answer. But let's not forget, we're not stopping here. The question says that what volume of distilled water should be added? Should be added. So should be added to 250 cm³. Remember, 250 cm³ is what? 0.25 dm³. Alright, so we can say volume of water or distilled water needed to be added equal to 10 dm³ minus 0.25 dm³. Alright, we have this. We subtract, we are going to get equal to 9.75 dm³. So we have this. So it means that the additional volume of the distilled water needed to make 0.05 mole per dm³ solution is what there? 9.75 dm³. So I have this. Now, I can use this formula to get my answer, and also I can use the normal formula to get our answer. So I have alright, number 2 now. If I'm done using the same formula for number 2, I'm going to use another method to solve number 1 and number 2. Now still get the same answer. Alright, take note, number 1 here we got 9.75 dm³. And we got 10 dm³. This is the volume that we got. This is the additional volume that we needed. Alright, number 2 now. We have C1 V1 equal to C2 and V2. Alright, let's list our parameters. Now let's check. We have this one here in cm³. This one here is cm³. but this one here is in dm cube. So what do? You convert them to dm cube. So now this first one becomes our v1, this is our c1, this is our v2. Now we're looking for our c2. All right, v1 equal to 20.00 cm cube, which we convert this to dm cube. We have 20 over 1000, 0 cancels 0, so we have 0.02. So we have 0.02 dm cube. We have this here. All right, our C1, which is our first concentration, is what there? 0.35 mole per dm cube. All right, our V2 equal to 250 cm cube. Converting this to dm cube, we are going to have what there? 0.25 dm cube. All right, our C2 is not given. Our C2 is not given. The next thing here is to make the C2 to stand alone. So we're going to have C2 equal to, all right, let me bring this formula out. I have C1, V1 equal to C2 and V2. So both sides by V2 over V2. C1 V1 over V2 rather. This cancels this, so this implies that we are going to have C2 equal to C1 V1 over V2. We have this. All right, C2, our C1 is what there? 0.35. We have 0.35. Our V1 is 0.02, so we have 0.02 over our V2 is what there? 0.25. So we have 0.25. All right, our C2 becomes, when we press our calculator, we have 0.35 multiplied by 0.02 divided by 0.25. All right, we get 0.028. So we have 0.028 mole per dm cube. So we have this. Now, this question here does not say that what additional volume is needed. So this becomes our final answer. For the first one, it asks us to provide the additional volume that is needed. So we have to subtract 0.25 from 10 to give us 9.75. If we are not asked to calculate the volume of water needed, there will be no need to subtract. This will become our final answer. All right. So for number 2, for number 1 we got this. For number 2 we got 0.028 mole per dm cube. All right. Now let me use the normal formula and see that we are going to get the same answer. All right. Now let me now use the second normal formula that is common to many students. The common formula is C equal to N over V, that is concentration equal to number of mole over volume. Now from the question the question says what volume of distilled water should be added. So it means here now volume is not given. Now we need concentration, we need mole. Now how do we find mole? We can find mole from this one here. We have 250 cm cube of 2 mole per dm cube HCl. From this one we can find our mole. So this last one becomes our concentration. So our concentration equal to 0.05 mole per dm cube. So how do we find our mole? We have 2 mole in 1 dm cube. Now, how many mole for this one now? For this one, how many mole are we going to have in 0.25 dm cube? So we have this. If you cross multiply, we're going to have x equal to 2 multiplied by 0.25. We multiply this, we are going to get our x to be equal to 0.50 dm, 0.50 mole. So we are going to have this. We're going to have this. So our mole equal to 0.50 mole. So we have this. So the next thing for us is to now find our volume here. We have C to be equal to N over V. Since we are looking for V, we just make V to be the subject of the formula by cross multiplying. So V times C give us VC equal to N times 1 give us N. Both sides divided by C over C. C cancels C. So we have V equal to N over C. So we have this. Now, our volume now equal to mole is what value? Mole is 0.50. Concentration is what there? 0.05. So if we divide this, we are going to get our V2 to be equal to 10 dm cube. So we have this. If we divide this, we are going to get this. Now, as usual, to find the additional amount of volume of the distilled water needed, we are going to subtract 0.25 from 10. And we are going to have our, so we are going to have 10 minus 0.25, which will give us 9.75 dm cube. So we're going to have the same answer. That's for number 1. Now, for number 2, we are having 20.00 cm cube of 0.35 mole per dm cube. From here, we can get our mole. So we have 0.35 mole in 1 dm cube. So what happens next? We're going to have what here? 20 over 1000. We have 0.02. So we're going to have what there? So we're going to have 0.02. So how many mole are we going to have in 0.02 dm cube? So we have this. If we cross multiply, we are going to get our x to be equal to, now 0.35 multiplied by 0.02. 0.35 multiplied by 0.02. So we're going to get 0.007 mole. So we're going to have this. So our mole equal to 0.007 mole. Alright, so we have this. Now, our concentration. Alright, so the question says, what is the concentration? So concentration equal to question mark. All right, we have gotten this, we have used this to get our mole. Now we have was diluted with 250 cm cube. This 250 cm cube, convert it to dm cube. We are going to have our volume to be equal to 0.25 dm cube. We have this. Concentration equal to mole over volume. So we have this. We have this. So we're going to have concentration equal to mole is 0.007 over volume is 0.25. Concentration becomes, if you divide this, 0.007 over 0.25. So we're going to get 0.028 mole per dm cube. So we're going to get this. So we're going to get the same answer. So if you find this video helpful, do well to leave a comment, like, share, subscribe, and follow us for more helpful videos as this. Do not forget, this is Ola Gold Academy. Bye.